RAM was yesterday. Trapezoid rule today, and we're going to review a little bit of RAM as well. Now, yesterday I remember I started to mention this, how rectangles are a great shape to use. Are there other shapes that we could use for these? Okay, I heard pentagon. Well, I don't know if I could really 4 and 5. Okay.
Just kidding.
Or isosceles triangles or circles. Okay, but not the best. Did you have a? Okay. So the one that is pretty good though is trapezoids, and there is a rule that we'll do for that. So trapezoids we can use. Here's 2 diagrams of that. You can see it looks pretty good here, right? Doesn't miss a lot of the space.
But it still misses.
So not bad. Trapezoids we could try those out. This will be equivalent. So this rule is actually identical to doing the average of the left and right rams, which on the next page we're going to do one example, and I'm going to show you that. Okay, first, do you remember this? This is the area of the trapezoid. 1/2 height, base 1 plus base 2. Now for our trapezoids, I kind of am switching the words here because for rectangles, I said like base and height. Okay? But for trapezoids, the height, well, I should say this. The bases are the parallel side. So this is base 1 and this is base 2. The height is along the horizontal axis. So when I say height for trapezoids, it is not up and down. It will be the horizontal length. All right, so I'll try and remind you that, but when I say height, it's the horizontal. So here's the height, these are the heights. For this rule, it only works if you use equal subintervals, meaning equal rectangles. Equal trapezoids, like the height, again, the bottom part here. So the heights have to be the same. What else do I want to say? All right, so here's what we're going to do. We're going to add up all of the trapezoids. So we don't know how many there are. So this is the way we will do it, is we write this dot, 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 like until we get to the last one. So here's trapezoid 1, 1/2 height. I put in y because the y, x and y, the y value will be the bases. Again, really that's, B is now the y values. Here's trapezoid 2, trapezoid 3, trapezoid 4, how many there are? Here's the last trapezoid. So we can add them all up. Just as with the rectangles, there's something common. Right? All of them have 1/2, and they have the same height. Remember, that's the bottom. All these heights on the bottom are the same. So we factor that out. Then we get this, the 1/2 h factored out. Now what we're left with is, so this is going to be the base, I'll call y0, the first base, and the second base, y1. For the second trapezoid, we had y1 and y2. So notice that this one was used double. See that? Because trapezoid 1, we use it as this base. Trapezoid 2 also uses that one. And then trapezoid 2 has this one, this base, y2. If I went to trapezoid 3, it would right here, it would have said 1/2 height, y2 plus y3. Because the third trapezoid will repeat this one, and then it will need that base. So I mention all of this because all of the middle ones, say it'd be y2 plus y3, all of the middle ones will be used twice. That's why the 2 is in there. So I always get the question, and I still will, I'll try to remind you, why is there 2 in the formula? Well, it's because the middle heights are used twice. One's for the left rectangle, one's for the right. For trapezoid rectangle. So we use that twice, that's why there's a 2. This trapezoid in the end only had this height once. So the end ones are only going to be used 1/2. Middle values twice, end ones once. The 1/2 comes down, the height, you can just find the height, but if you remember from yesterday, this is how we found the base of the rectangles, which is now the height of the trapezoids, b minus a over n. So this is really the formula. If you don't like that b minus a over n, it's just the height. I say it right here. The height is b minus a over n. Here's a little example, and and here's where I said this is actually equivalent to left plus right divided by 2, that average. So we're doing on the next page where we work it out. Any initial inquiries? Questions? Okay. Well, let's flip the page to the next one, and we'll try this example. So we're going to do x squared. Actually, one we already did. X squared. So we know x squared. We don't need the left side, but x squared is like this. Here's 1. Here's 2. So I'm showing you, we're really finding this area under the curve here with trapezoids. Actually, think about it. Trapezoids are pretty good for this. Right? They're pretty darn good that they're going to match up there. So
How do you know it's 1 and 2?
that's a good point as well. Thank you. So I'm going to start incorporating that symbol with area under a curve. So remember that when there was no values here, it just meant find the antiderivative of this function. Right? When it's with area under a curve, it means find the area between these two. This is like, it just means A to B, 1 to 2. It just means on that, it tells us the interval, 1 to 2. Thank you. I forgot that I hadn't talked about that before. So we're doing 4 trapezoids, n equals 4 trapezoids. We're going to use the trapezoidal rule to estimate the area under the curve for x squared between 1 and 2. So that's what it's just saying, between 1 and 2. Okay, let me kind of do number line thing where I get the values. So on the ends here are 1 and 2. And if there's 4 trapezoids, they have to be of equal length. So that entire length is 1. And then we divide by the number of trapezoids, which is 4. I'm going to write that as 0.25. Is that all right? 1/4, 0.25. So I need to go 0.25 to the right from 1, and I'll be at 1.25. Another 0.25, I'll be at 1.5. And another 0.25, I'll be at 1.75. So that's really the subintervals. Okay. And now I'm going to set up the area. So I'm using the trapezoidal rule. So it starts off 1/2. It's always in there. Then there's the height. And the height is now the bases. It's all of these along here. They're all the same. It's that value, right? 0.25. Used to be the bases of the rectangle. Now it's the height. So that's 0.25. Okay. And now I'm going to do the first one once, the endpoint ones once, and the middle values twice of the bases. So let me go back to this. Let's go to the bottom. So I did the 1/2. I did the height. Now I'm doing just the first y value, 2 of the second one, 2 of any of the middle ones, and 1 of the end ones. So these are the bases, up and down. All right, so I'm going to write it as f to start here. So I need 1 of this one. So I'm getting that y value there, that base. I need 1 of those. It's the end one, f of 1. I'll put that in calculator in a second. Plus 2 of any of the middle ones. So the next one, you can even see here the 2 trapezoids, right? It's this one, and I would do it twice. So that is the height at 1.25. 2 f of 1.25. In the next trapezoid, I'd be at 1.5, and I would need 2 of those. 2 of those. 2 f of 1.5. Next, 2 of the 1.75. And then, actually I have one more here. The last trapezoid, I only need 1 of that outside height. So plus 1, or I'm not going to write 1, but f of 2. Also, so if you remember yesterday, left ram, when we break this up, we'd use just the left 4 of these. Right ram would use the right 4. Midpoint ram would get the ones in the middle. Trapezoid uses all 5. It's kind of interesting how that works. Okay, now something I want to show you here is this would be not the worst to enter these in the calculator. I had like 1 squared for this one. Next one is going to be 1.25 squared. Not the worst doing it all. But I want to tell you in the calculator, an easy way to help you out is to use y equals. So if I enter just the function x squared here, and then I look second table, it's going to tell me all the numbers. And you're allowed to do that. Okay, you're allowed to just look at your table values. Now on this one, we're going by 0.25. So I didn't change the table. So I go to table second and then window table set. So I want to start at 1, table start, and then table, that's the change of the table. I want to go by 0.25. Now I go back to my table, and it tells me all the values. Okay, so yes, you are allowed to use these. All right, and I encourage you to use them. Saves your time. One other thought before I write them down. Sometimes I've seen students who write these y values. They know they're going to use them, so they kind of do this. This is the x, and this is the y, and they just list them like this. 1, 1.5, 625, just so they have them. They know they're going to need them. 2.25, this one's 4, and this one is 3.0625. So I don't care how you organize it. I'm showing you. I've seen students do x for that. That's the interval, and then y. I like to chart it right there. So, anyways, let's finish it off. So I'm going to just plug in the numbers, and then we'll put it in our calculator and be done. So f of 1 was 1. 2 times f of 1.25 is the 1.5625. 2 times the 1.5 is going to be or f of 1.5 is 2.25. 2 times the f of 1.75 is the 3.625. And f of 2 is 4. At this point, you just put it in your calculator. What do we get? So some of you are still going. Yep, so 2.3437. Right. So any
So you don't want to surround it all?
excuse
Just
me.
give it exact.
Correct.
Okay.
Any thoughts about trapezoid rule? Trapezoid rule. Always a half, then the height, all the bases in the middle, which are the y values. You need 2 of any one in the middle. 2 of any one in the middle. Well, let me show you how, if we did the average of left and right, I'm going to do the same as this. So what I'm going to do is the same one. We already have a lot of values. We'll look at the table. I'm going to do left and right ram. This would be good to contrast them as well. All right, so we're back to rectangles. Let me just draw a little picture. So it's x squared. Here's 1 and 2. So now we're back to rectangles, and if we do left ram, it's left endpoints. Okay, like that. And it does say n equals 4 still. So I just want to show you, we're still doing 1 to 2. Okay, left ram. So we're back to base times height. All the bases are the same, and it's still 0.25. Previously the height. From 1 to 1.25, they're all 0.25. So I factor that out, and now I'm going to list all the heights of the rectangles. Again, I already have them all. They're up here. So remember, if it was left ram, my first height is at 1, and the height at 1 is 1. See, I'm looking right here. Then the next one is the height at 1.25 for this rectangle. And that's this y value, 1.5625. The next rectangle is the height of 1.5, which is 2.25. And the last one is a height at 1.75, which is the 3.0625. Again, for left and right ram, you will not use all 5 of those coordinates. 1, 2, 3, 4, 5. You only use 4 of them, the left 4. Because for 2, No, we're not doing 2. We're doing a rectangle that gets to 2 in the x-coordinate, but uses a height on the left side. Let's put that in a second. Right rem, remember how there's only a slight difference here? Very, very slight difference. Is I'm doing rectangles that are the right endpoint. So like these ones in blue. But now, oh, that drawing. I'm sorry. This drawing, everything should be over. Oh. I don't know what's going on with this. It's just failing on me. So the right endpoint 1 would be everything the same, but we'd have 2 in there. We'd have 2 in there. So we still have the 0.25, and then we start at 1.25. So it would be 1.562 f of 1.25, and then we do f of 1.5, which is the 2.25. Then we do the 3.0625, and then f of 2, which is 4. Okay. So if you do the left rem, I know I just erased, but you should get 1.96875. And for the right rem, 2.71875. Then what you can do is compare. You do an average of these. Left plus right divided by 2. And you're going to see that it's the same as the one above. So I just want to show you here. So I go 1.9 plus 2.71875. I do an average by dividing by the 2, and that is the same number from the top. So you do an average, and it's the same as the top. Okay. This really hurts. I was going to show you, so I was going to compare from above and show you. It's going to be tough to do now, but if you look at the values in the trapezoid one, you should see the half. That's where we do the divide by 2. Then we have the 0.25, which is these. So this, I'm showing you the trap. Okay, and then for the trapezoid, you have 1 of the first one and 2 of all the other ones. Well, if you look through the left and right rem, you'll count 2 of all these in the middle. In left rem, you would have seen it as well. So if you look at your paper, you see like 2 of the 1.5625 left and right. But on the endpoint ones, you only see 1. You see the 4, and then for left rem, you would have seen the 1. So what I'm showing you is all the values from left and right combined. 2 of these, 2 of these, 2 of these, 1 on the end. It combines to be the exact same thing we did in trapezoid. Exact same numbers. So hopefully that made a little bit of sense. It's kind of hard when my board froze there. So let's see if there's anything else I want to say on that. I'm going to skip the midpoint rem. I think we did a nice one of those yesterday. I'll finish up with a table one on the next page. What can I answer though?
Are the trapezoids more accurate than?
I guess they could be a little bit, but as you go to infinity or as you go to 100,000, doesn't matter. Yeah. So maybe a little bit. Just like the midpoint one is a little more accurate than left and right, but as you go to it doesn't matter overall. Okay, so let me pull this back up. Let's flip the page 7, and do one last one on the top. So this is a table version. Oh, it's down here. Okay. Use left rem, right rem, and this is wrong. Here's is right. Trapezoidal sum to approximate the sum from the given table. So the first thing I want to say is this is not trapezoidal rule. you could use the trapezoidal rule. However, on this one we're going to find we couldn't actually do it. Table versions. There's two types. There's just here's a function one, here's a table version one. You can't do trapezoidal sum, or trapezoidal rule. We can still get the trapezoidal sum though by doing the left ram plus right ram divided by 2. Just doing an average. So what I'm going to do is left ram and right ram for this one, and then I'll do an average. Okay, so we saw here, this means on an interval from 0 to 10, we don't have a function. We have values, x and y, from the function. We don't have an actual function. But this will be enough. Now, as soon as you get good with these, you don't have to draw a picture, but I do like to show you what's going on. So here's a rough sketch. 0, 5. All right, 0, 5 is 1 point. The next point is 4, 3. Just a rough sketch. 6, 2. 7, 3. And 10, 5. All right, so basic sketch there of the points. I'll draw a picture of what left ram is doing, what it looks like. First rectangle is left, so left height. Next rectangle from 4 to 6, I start at 4 for the height. Next rectangle 6 to 7, I start at this point for the height. At 6. 7, I start at the height and I go over to 10. So there's 4 rectangles. This is the other thing, they don't tell you how many rectangles there are. But there are 5, 1, 2, 3, 4 of these x coordinates, and you go left and right, uses one less of those. Okay, what you should notice is the bases are all different. Bless you, right? 4 here, 2 for the base there, 1 here, and 3 there. They're all different. So you cannot use, I cannot factor out. So no GCF here. You just have to do all the rectangles separately. All right, so here we go. Left ram. I'm going to do base times height. The first base is 4. And I'll show you in the table as well, because you might not always draw this picture. I'm looking right here, 0 to 4. That length is 4. I'm doing left ram, so I want the height at 0. The height at 0 is 5. So that's rectangle 1. Rectangle 2. Yeah, rectangle 2. Let's just pick it up right here. This is a great slide. Rectangle 2. So what was the numbers? Can you help me out? 4 and something on the first one?
4, 3.
4 and 3. Okay, so I think the next one was a 2.
6, 2.
The next one is 2. My drawing. It was 0 to 4, and then this is 4 to 6. So the base is 2.
Oh, it's not.
So the base is changing?
Yeah, the base is different in
changing?
all of these, yeah. And you can't factor out, the base is different, so I can't factor out a number.
And the,
Yeah.
I think the 3
It's
is
not
actually a 5.
So the height is going to be, oh.
The 4 for the 3 is a 5.
Yeah. It's 5.
It's a base of 4.
Thank you.
It's 2.
So yeah, so the base is 2, what's the height
3.
is 3.
Yeah.
The height at, on the left side, at 4 is 3. Plus, so then the next one was from 6 to 7, so it's 1.
2.
And then the left height at 6 is 2. Yeah. See, really these, I kind of like the table ones. Once you get the hang of it, they're pretty quick and they're usually whole numbers. 7 to 10, right? So that's 3.
5.
And then the height at 7 is 5, or 3.
Wait, 7?
Because we're doing left ram, so we're doing the height at the from 7 to 10 makes a rectangle. You want the height on the left, which is at 7. So this is left ram. Okay. Nice. So we add them up, put them together. 26. You can get like this. Just put them in 2 and 9. So 26, 11. So 37. let's do right rem. And again, you'll see a lot of similarity here. So the bases don't change. First of all, I can write them in right now. So 4 times something, 2 times something, 1 times something, and 3 times something. So rough sketch of that. It's 0, 4, 6, 7, 2. So we're doing rectangles 4, 6, 7. This is not a great scale. I don't know what it was. Hey, 0 to 4. So the base is still 4. 4 to 6, the base is 2. 6 to 7, the base is 1. And 7 to 10, the base is 3. So those don't change. The same as they were over here, these 4. Length of 4, length of 2, length of 1, and length of 3. But then we're using the heights on the right side. So now from 0 to 4, the right height will be at 4, and that one is 3. Then for rectangle 2, from 4 to 6, the right height will be at a height of 6. And at 6, the y value is 2. From 6 to 7, the base is still 1, but the right height at 7 is 3. And then the right height at 10 is 5 on the last one. Alright. Oh, so we should put them in 12, 4, 3, and 15. 16 and 18, so we got 3, 4. Finally, to wrap up, trapezoidal sum, not the rule, the sum is the average of those. So I can just do left plus right divided by 2. So that was the 37 plus the 34 divided by 2. 71 divided by 2, so we get 35.5. So yeah, sorry that crashed there. So table 1, you cannot use GCF. You have to do individual rectangles. You cannot do the trapezoidal rule because the trapezoidal rule requires that the bases, or I guess the heights, are all the same, which they won't be on this. You also, I don't know if I mentioned, you can't do midpoint ram on this. I don't think I mentioned that because you would need 2. You would need the height at 2. You don't have it. You need the height at 5, the midpoint at 4 and 6. You don't have it. So left and right is the only one you can do, but then you can do the sum. Any answer on that?